such devices, and we want to use in this aim our test facility with intense numerical modeling. So average wind speed for all these months. We have this data gathered at the moment. What is also interested for such devices located in the city center, daily profile of wind speed. And for example, what we can see, it is that the fastest wind speed is reported near midday, and during nights the wind speed is decreased. It is connected with operation of sun, because sun hitting the city, hitting the buildings, create conditions for wind generation. So pattern of wind generation is different in cities, in urban conditions, comparing to open space. And for example, it is visible in this screen. What we can see here, it is that on our test facility, we don't have a good condition related to wind rows, because our predominant direction for turbines is west-north, and in Kraków, in our city, the predominant wind direction is from southwest. So, for example, the first conclusion is that we should select building oriented with this direction. Also, some data illustrate behavior of the wind. For example, if we create power spectra and plot our power spectra on the general Van der Hoeven spectra, we can see that these meteorological peaks are similar. However, for short frequencies, behavior is different. We can see some strong resonances which are related to some other behavior of the buildings. For example, with short time correlation of wind speed. So this data can be created for all signals, etc., and we can analyze exact behavior of this data. Just short example. What is interested if we consider such installation of such devices, it is of course its impact to the buildings. Therefore, what is very important, it is noise generated by such devices, and also vibration, influence on construction of the buildings. This scatter plot presented all 1 year data with noise generation. And for example, we can see here that for wind speed from 0 to 40 meter, we cannot observe any enhancement, any enlargement of noise. It is simply a range of ambient noise from street, and then additional noise appears if wind speed is larger than 4 meters per second and grows slowly. Of course, as we consider for other buildings, living buildings, it is has no influence because it is in shadow of noise generated by wind flow. And what is very also interesting, that if we consider vibration, some resonances are visible. Resonances are result of some resonances of building construction, etc. Some mounting elements. So, for example, we can see strong resonance for if rotation per minute, I mean blades, is in the range of 200, 300 rotation per minute. And also for for fast rotation, for strong wind, when number of rotation per minute is larger than 600. So therefore we can gather some data on the building influence if some problems could appear if such devices will be installed. Of course, other point of view for vibration and for noise, it is something like power spectra presented here. Especially for noise, we can see some 1 hour, half hour peaks. It is mostly related to operation of some building system, for example, ventilation, etc., when it is starting from time to time with special algorithms. So on this background, we can see influence generated by our devices. General data from mechanical and from power generation and presented here on this three-dimensional plots. Also scatter plots presented all this data, 1 year data. You can see, for example, here what is generated power in function of wind speed, in function of tip speed ratio operation. What is important for this case, that we have some maximum for wind speed, that the best...
Marius, just to let you know that you have to finish in a minute.
Okay, so this is gathered data, and generally some CFD model which describe this data created due to complexity of all this situation. So we created CFD model with all this grid, etc., and you can see some wind flow for some cases, southwest wind, for some selected wind intensity. You can see how it looks like. This is area of wind turbines, flow near the wind turbines. So you can see that the direction is quite complex. So south wind, west winds, similar pictures. Of course, the presentation is available for comparing. So southwest winds, etc. And finally, some plots of velocity V1, V2, and some validation model comparing with data. So you can see that it is not totally good, but it is still under improvements. We have some work to do still. And finally, my conclusion is that this is can be a good option for increasing sustainability of buildings, so increasing impact of wind energy just integrated with buildings. However, it requires development some tools for selecting buildings among some plenty of buildings inside the city to develop procedure. And we believe that using our test facility and our software, it would be possible. We will simply develop such a device. So thank you very much. I'm sorry for extending the time.
Thank you also, Marius. I think that we can afford one very quick question. Yes, Professor Duic.
Thank you for very, very interesting presentation. Regarding the noise, you have shown that the noise is usually between 45-65 decibels. Mm-hmm. Which is not insignificant. And the question now is, I didn't really understand what are the frequencies of that noise, because the low frequencies noise is what bothers people. If it's higher frequencies, it will be just white noise, and they will probably not get nervous too much. But if it's low frequency noise, I have an issue with my neighbors with heat pump, which is under 45 decibels, and they still hear the low frequency noise.
Yes, I agree, but situation with noise is with exact analysis of the noise is quite complex, because our sensors are mounted just on the wall of this building, and we have street noise because it is just 50 meters above the very with heavy traffic street, and also it is quite close to some technical equipment of the buildings, some ventilation system, systems from a technical system for removing polluted air from laboratories, etc. So I think that to give a detailed analysis of the noise, we have some apply some procedure for selecting noise from our facility and remove background noise. The background noise is quite complex. We try to do it when our turbine simply doesn't work, no wind. So I think that more detailed noise analysis will be available soon, and we will be sure that it is only noise from our device. Yeah, I agree that low frequency noise is problem, can be considered as a problem for some people.
Okay. Thank you very much for the presentation and the discussion. And now we are passing to the next paper, which comes from Serbia. So I would like to invite Dejan Ivezic to take the floor.
Hello, everyone. I will just share the screen with you. I hope that now you have my screen on your PCs.
But if you can turn to, yeah, that's fine, perfect.
Okay, yeah, I'm going to speak about some small project which we realized last year for the Serbian Ministry of Environment, and the point of the project was the using of sewage wastewater heat in district heating in Serbia. We did some small analysis about the effects of such systems to the sustainability of DH systems. Actually, the motivation for the research was initiated by the following facts. Cities are responsible for about 70% of world's energy consumption. The major share of energy consumed in urban areas is related to heating needs, and still fossil fuels are dominant there with approximately 75% of consumption. Of course, the heating system, as we all know, will have very important role in the energy transition process. So the wastewater heat can be considered as an alternative, renewable and locally available energy sources. However, still in the global scale, this energy source is still mostly unused. Currently, sewage waste heat in Serbia is not utilized at all. Moreover, there are no available data about sewage wastewater heat potential at the level of states, regions, or cities. Research presented in this paper is aimed to estimate the sewage wastewater heat potential and to evaluate some of the effects that could be obtained through its utilization for heat production in the existing district heating systems. Actually, the research which we conducted had three phases. The first phase or the first section of the research was aimed to provide an overview of current state of existing district heating systems, support with values of selected key performance indicators for the base year. That is this blue, let's say, blue line, dash line on the screen. The second section is related to the estimation of the potential of treated wastewater. The aim was to estimate the amount of heat energy that can be produced by heat pumps and delivered to district heating systems. That's those two boxes here on the screen. So in the third phase, we evaluate the utilizing full potential of wastewater heat by developing the projections of district heating system with changes on the supply side, while the demand size was kept as current. So here is that future where we use that heat potential, and we calculated the indicators to see what could happen if we use this potential. For evaluation of the potential, we use some indicators which are presented here. We calculated, as I said before, for the current state and for the future state. So we calculate primary energy factor, import dependency, fuel mix diversification, share of renewable energy sources, and emission, CO2 emission. The definitions, I believe, are well known, so it's not necessary to speak about them. About the Serbian district heating systems, for those who are not familiar, they exist at 57 different towns in Serbia. You can see it here on the map. The total installed capacity of district heating plants is over 6,500 megawatts, and approximately 20% of total number of households in Serbia and something about 44% of households in the cities is supplied with heat from district heating systems. Currently, heat production in district heating system is completely based on combustion process, and fossil fuel are dominantly used, something like 99.5%. You can see it here on this graph. Natural gas is dominant, some share of coal and fuel oil, and just less than 1% of wood fuels. Locally available energy sources like municipal solid waste, waste heat from sewage water, wastewater, industrial waste heat, and some other sources which can be efficiently used in district heating systems are not utilized at all. The fuel with the highest share in those systems is natural gas, as you saw before, and it is dominantly imported energy source. Import is performed through a single import route from Russia, and gas import dependency is over 80%. If we add the oil import dependency, which is also over 75%, we get here 71.7% of import dependency of this energy sector. High values of primary energy factor here, 1.52, and of course CO2 emission are consequence of fossil fuel based heat production, what is of course expected. The share of renewable is very low, as you saw before. There are only seven wastewater treatment plants in operation in Serbia. Actually, there are 7 constructed wastewater operation facilities, but only a few of them, 3 of 4, are in a real operation. So we used one of them, which is located in the city of Shabatz, and made some analysis of potential of this renewable energy source. But what is, let's say, positive, that in the few cities, construction of wastewater treatment plants are taking place, while in several cities, preparation of project is initiated, so construction of wastewater treatment plants can be expected in the near future. This facility in Shabatz is one of the most contemporary, and we use, as I said, for evaluation of sewage wastewater heat potential. For estimation of heat energy that can be produced by heat pumps, we use data on temperature and flow rate of treated wastewater. And based on assumption of the temperature drop in the heat exchanger of 4% and the value of the coefficient COP3, the heat pump capacity of 7.2 megawatts was selected. This heat here is the low duration curve of the existing district heating system in Shabatz. Of course, we assume that the heat pumps will be used for the base load cover. We calculate here the heat that can be produced per inhabitant. It was important for us for the analysis about the energy which can be used in the other location in the country. And what is not visible here, I would say it that, for example, even in the winter period, the temperature of wastewater is over 11 degrees centigrade, and flow is something over 160 liters per second. So we use that potential for this heat pump operation. Of course, the heat energy can be produced. The heat energy that can be produced using wastewater heat in Shabatz was the base for estimating the amount of heat that could be produced in the existing DH systems in Serbia if heat pumps would be widely implemented. The main input parameter was the calculated indicator of produced heat per inhabitant. Utilization of the potential of treated wastewater by heat pumps in all Serbian cities with DH systems would result in the production of 6,360 terawatts of heat. As a consequence of the introduction of more efficient technology in the heat production, the primary energy factor will be reduced to 1.46, as you can see. And but what it is important to understand that this factor is very high as a consequence of structure of fuel mix in the Serbian electricity sector. Because for the operation of the heat pumps, we planned using electricity, and still we are mostly based to lignite in the electricity production. Total energy savings, including production, transport, and conversion, are determined to something more than 1,200 terajoules, which is approximately 5% of energy currently used. The using of locally available renewable energy source increased from 0.5 to 10, more than 10%. And in addition, using this wastewater heat potential, reduce import dependency of the DH systems to 64% and provides a more diverse energy mix. Of course, still the CO2 emission is lower, but again, because of the electricity production from lignite, still it's quite high. But as you can see in the heat production, if we consider all heat productions, almost 1/4 could be provided from the heat pumps and this renewable source. For the discussion, in the paper we have presented results that can be expected in the largest Serbian DH systems. That is not present here on the presentation, but in the paper you have in detail, let's say, those data. It is shown that the effects varied in different DH systems depending on the fuel mix in the base year. specific efficiency of heat production and distribution, but also depending on the share of households connecting to DH and the number of inhabitants. Therefore, for obtaining optimal positive effects of heat pump introduction and before investment decision, every DH system requires more detailed analysis on production and consumption side. Overall analysis indicates that the introduction of wastewater heat pumps would have multiple positive effects. Primary energy savings of 5% per year due to the introduction of more efficient technology with the same efficiency of the consumers and the level of comfort. Also reduction of CO2 emission of 6.5% per year by introducing this alternative renewable energy source and substitution of coal, heavy fuel oil and natural gas. Of course, reduction of import dependency of DH system for almost 10%, making them less vulnerable to unpredictable fossil fuel price variation and interruption of supply. Improved diversification of energy sources for 21% by introduction of locally available renewables energy sources. Introduction of wastewater heat pumps in DH systems will be an example of responsible energy production and consumption that should provide affordable and cleaner heat energy to consumers. The planned process of building wastewater treatment plants in Serbia should be followed by detailed analysis of possibilities for their integration in existing DH systems. That's for me from the presentation, and now I'm ready if you have some questions.
Thank you, Dejan, for this very insightful and interesting presentation. Now we have some minutes for questions. Please, the floor is open for questions. Nothing in written. I don't see any. Okay, Professor Dujic, please.
Thank you for a very interesting presentation. And I think I agree with you that there is a significant potential. My question is, I didn't see, maybe you said so. What is the location of heat pumps? Is it after treatment of wastewater on one single place, or it is distributed? Because I remember a paper showing that even distributed heat pumps could work. The problem is the reduction of temperature that would be detrimental to the collector, to the biofilters, but it's not too big. And the other problem, of course, is that before the collector wastewater is not very clean, so you need a different type of equipment. So what is your concept?
Yeah, the both concepts are, let's say, acceptable, and all of them have some advantages and disadvantages. In this situation here for Shabac, we consider using wastewater after treatment, so we use so-called clean water. And actually, we made a different combination of heat pump location. But actually we find that is more suitable, for example, especially for that location, for the case of the Shabac, actually to transport clean water for, let's say, something like 2.5 kilometers, but in the isolated pipes, so to reduce heat losses as much as possible, and then to, let's say, put the heat pumps near to the facility of the district heating plant. Of course, the reason is, another reason is that we are in the urban area, so we don't have a lot of, let's say, space to put the pump. So we find that it's more the best location just nearby the plant. For example, in Valjevo, they have better situation because the heat plant and treatment plant are actually in the door by door, so it is very simple to transport the clean water to the heat pumps. So in this, as I said, we use the concept of heat pumps located near heat pump, near district heating plant.
Thank you.
Thank you. I don't see any more raised hands.
There is one question in Q&A.
Yes, I will read this. Thank you for an excellent presentation.
You can also ask Shir to ask. I have given her ability to speak.
Okay, Shir, can you
Thank you very much. It's a valuable opportunity.
can you present your question, please?
Yes, it's a valuable opportunity that there's a 6.5% reduction per year based on the wastewater utilization. At which stage is this being communicated to decision makers in Serbia for the examined city and possibly other cities in the future? Thank you.
Actually, this was our idea was because, as I said at the beginning, we did for the Ministry of the Environment, and we want to find what is the potential of this, let's say, renewable energy source. There is actually ongoing plans. There are two EBRD projects. One is for Shabac and another is for Valjevo for introduction this renewable in district heating systems. For other cities, actually, we have only one more wastewater treatment plant in Subotica, which is actually in operation. But as I know, three or four more locations are now under construction, and I hope that the results from Shabac and Valjevo will be some kind of initial impact that they introduce that renewables also in their energy mix.
Okay, thank you. I think with this we have finalized this presentation. Thank you, Dan. Thank you, the other participants for the questions. And now we are quickly moving to the next presentation. I'm giving the floor to Lavinia. Lavinia, please.
Excuse me, Natasha, because I have two presentations, do I have to present the interoperability between BIM and CVE?
Yes,
an acoustic.
That's the one which is planned as a fifth
Okay,
on the agenda.
Can you see my screen?
Yes.
And can you hear me correctly?
Yes, please just make it, yes, everything is okay.
Okay, perfect. Thank you for being here together. This presentation is about a work with Mia Shushnik, which is a master's student at the BIM A+ European Master, me, that I am assistant professor at the University of Brescia, and engineer Maria Caliroli, that is working at Politecnico di Milano. We are here to discuss twofold topics about interoperability between building information modeling and calculation virtual environment for energy and acoustic analysis. And we use this concept of interoperability to understand how exchange the information between digital environments without a lot of errors or nearly in a complete way. And BIM is in building information modeling, which is a methodology for virtual construction of a digital building, object-oriented, parametric, geometrical, and semantic data throughout the whole life cycle. And we defined CVE as calculation virtual environment because we want to include in this definition all the software and calculation environment that are used for specific analysis to support the optimization process of the building. So our idea is to understand why we need this interoperability and how we pursue it. And we need to increase accuracy and consistency of the data between the team of evaluation of the architectural and the specific calculation of performance for the building. And we can try to reduce the time for this kind of interaction, reducing consistencies and loss of information. And we can have a building performance analysis at the first stages of the design, where it's easier to implement choices that could improve in the whole life cycle, and with a reduced cost, the performance that could be energetic and energy related and acoustic. So we work on the part of energy through this workflow with different software using as a BIM the Revit model, and we tested different paths with ISB design builder that is using the Energy Plus engine for calculation, and so we exchange the data through the GBXML file and IFC to understand how it's possible to transfer the geometrical data and the semantic data to the different environments. And then we use the BEM tool, so the Building Energy Modeling tool, to perform simulation and to get the outputs in an IDF file, which is the file used in Energy Plus. For the building information modeling to the acoustic parameters evaluation, we started into checking the different software that are available now to calculate the acoustic performance of the building. We have CAT, COMSOL, and other software, but it's, there is no interoperability between the BIM and this software, because you need to implement for all the acoustic parameter the data inside this specific environment, and there is not a connection. So our idea is to try to work directly on in BIM, and we develop a script to work in this direction. So we have the BIM authoring tool to generate the BIM file, and we use the geometry to support the performance, the acoustic performance simulation. So we used these two workflows for the BIM to BEM part. So from Revit through the GBXML file to Design Builder as a graphical user interface, and then we have the energy simulation in Energy Plus with through the IDF file. And we tested the second path with starting with the BIM model in Revit, and we tested the IFC and the GBXML file to transfer the data into the ISP software that is using Apache SIM as a calculation engine. Then for in the second part, we have the BIM to AB, and we use the Revit as a BIM authoring tool, and we use the add-in Dynamo to calculate different parameters that are used for the acoustic calculation in the current regulation in Slovenia, because Mia worked on this case study with the regulation in her country. The case study is a floor of a school building. We focused on school buildings because there are requirements about the acoustic performance of the spaces, because of the learning performance of the student is also related to the possibility to understand the speech of the teachers, and so it's a specific. There is a specific attention on this parameter, and we use it also for the energy part. We have 380 square meter as a total size. We can see that it's a traditional distribution with the corridor and classrooms, and then we have the restroom and the entrance that are not specifically interested in the simulation. Sorry, there is a, I'm sorry. Okay, so here we can see for the first part, the preparation of the model, in which we use the two format IFC and GBXML file for transfer the data to Design Builder and ISB. And we start here there is the workflow. We define the geometry and materials and thermal properties for the energy calculation. And there is the definition of the location, the assignment of energy setting of the building to the spaces, and the analytical model that we created starting from the architectural model to the analytical model, as you can see in the picture. And then we have the thermal zone, and when we have the thermal zone, we could export as a GBXML file and check it in, check the process and the data that we can transfer, and we did the same with the IFC file. For the part 2, we use the geometry from BIM. Currently, the analysis are performed using the geometry and the manual application of the acoustic parameters in the software for the acoustic parameter, as in the acoustic calculation. Here we perform the acoustic analysis inside the Revit without export, and we try to work to avoid the manual insertion of parameter, and we work with the Dynamo scripts. We used as a parameters the reverberation time, the optimal reverberation time, as a comparison to understand the acoustic performance of the spaces, and the Schroeder's frequency, because they are the main parameters that are used for the evaluation. So here we have the result. We use specific tools for checking the import, the export from Revit and the import in the environment, because we found that in some cases we have the export, but then we couldn't find the data in the calculation virtual environment. And then there are different levels of accuracy of the export about the shading elements in ISB and Design Builder, depending on the format. And so we tested different options to understand the reliability of this kind of interoperability processes. In the table, you can see a summary about these first findings. The export from Revit to the GBXML file to ISB has a zero discrepancy about the geometry values, while through the IFC we can find some possible differences because of the central line and different thermal zones that are created in the BIM model, and the use of GBXML file to import the data into Design Builder has also some discrepancies that you can see here that can reach the 20% and 24% in the first case. Then we checked the import of the different space and specific function, because it's used also for the performance calculation. And we found that the GBXL in ISB imported spaces, while IFC did not, and Design Builder uses activity templates. So we checked all the steps to understand if we have the geometry, but also the information about the thermal characteristic of the material, of the spaces, and the energy settings of the different parts. And then we have this setup of occupancy. In the GBXML spaces are imported in the ISV as occupancy data, while IFC is partially importing data and uses the activity templates. Here we have the information about the electrical loads, because for the energy calculation, we need more information that are not only related to the spaces, but are included into the analytical model. And we check the spaces, and we try to summarize in this table some evaluation criteria, and the full interoperability is not reached, but is quite complete through the GBXML imported in ISV, which is a very also accurate software for energy calculation. And we can see that we have maybe to pay specific attention on how to create the BIM model for the export to avoid the problem in the geometry, but we have the location, dimensions, spaces, and building construction, occupancy, and electrical loads that are imported. Maybe we need to set up the outdoor information manually. And we can have also the import of the SDEWES SEE information, while the import in design builder is more about the part of geometry, and then the interoperability is not complete. For the second part about the acoustic, here you can see the dynamo player that we created for realizing the calculation of the acoustic parameters. We have we set the room parameters with the acoustic parameters that we have seen before about the reverberation time and Schroeder frequency that are related to the different spaces. And then we have the calculation part that is related to the selection of the room in Revit and getting the desired area, reading the values of absorption coefficient from a database. So we connected the BIM model to a database that could be prepared about the specific characteristic of the spaces in Excel. And then we have the import, the reading of the value, and the setting of the value in the room parameters in Revit. So we have the calculation setting when we can select the room and run the simulation and have the selected values, and we have it automatically that we can find in the model. And we can also visualize into the floor plan. If we have a color code, we created also an instruction message that remember us the color legend. So if it's red, the reverberation time is higher than the optimal value. If it's green, it's lower or equal. And if we have a gray color, it's not applicable because, for example, in the corridor, we don't need this kind of evaluation. And then we can see an example calculation for the different classroom. And then we have a step of clear visualization to restart the process, because we think that we need an iterative maybe process while we are exchanging information through the different discipline in the design team, because maybe we can check different materials or different strategies to improve the characteristic of the spaces. And so we for the first part, we found a great difference when comparing the different approaches that we selected through the IFC or the GBXML and the different software. And therefore, interoperability includes much more than just the building geometry. Importing a GBXML file into ISV retrieves almost all the data from Revit, while the other two approaches have proven less reliability. And in some
just to mention that you have to finish in a minute. Please.
Okay. So we summarized our results. So we found also a difference in the calculation of the U value that we can have in Revit and in the calculation virtual environment, because Revit is only calculating the conduction, because it's not a tool that is working on the energy performance, that is just selecting materials. So we need to be sure about the thermal characteristic checking in the calculation virtual environment. And our work wants also to be a guide for the users. For the BIM2AB, we have seen that we started into working into Revit because there is not a interoperability with the other software. And we use an extension of the BIM for this kind of performance assessment. And we can work with the BIM model and the database for the materials, and we work to realize a user-friendly tool, and that has some limitation about in this moment. For example, the volume and the shape of the rooms, but it's a first step. And also for the classroom, we have commonly standard size and shapes. And as a conclusion, we can say that BIM is a tool constantly under development, and interoperability remains an obstacle due to the constant development of simulation tools that are not strictly connected in the same environment, but we need to understand the discrepancies that we need to check during this process. And we presented an overview to contribute by pointing out strength and weakness of the two most promising software for energy calculation and the export file format. And then the BIM authoring tool, together with programming languages as the Dynamo, forms a powerful tool to improve the calculation of performance that can support the sustainability of the tool and the quality of the space. And here, me and my colleagues, thank you for your attention. And if you have any question, I will be glad to answer. Thank you.
Thank you, Lavinia. I think that we have time only for one question. We have a question in our QA box. It comes from Stanislav van Weiler. Dear Lavinia, thank you for this interesting presentation. First, you describe BIM to BIM, and then is BIM to APE. Is it possible to combine these two approaches into the building modeling environment? Maybe an index or parameter which will contain all the information on energy and acoustic for the specific building or area. Can you reply, Lavinia, to this question?
Okay, thank you for the interesting question. It could be very useful to have the combination of energy performance and acoustic performance calculation in this moment. The first idea that I can try to propose it could be to create, as we did for the acoustic criteria, acoustic parameters, other parameters related to the energy performance. And so we can try, we did some experiment about calculating the calculation virtual environment, the energy performance of the building, and to import this data as a quality of the spaces in the BIM. So it's not possible to use the same environment for the calculation, but we can try to work with the bidirectional relation between BIM and the calculation virtual environment also for the energy calculation. And we can try to enrich the spaces with the information about acoustic and the information about energy. Or if we want to work on a dynamic energy performance calculation, Another option that I can imagine in this moment, it could be to use a static approach for the energy calculation. And maybe in this case, we can imagine to create a script to calculate the thermal balance of the space and to use the same kind of approach. So using the visual programming language to calculate not the dynamic energy performance, but the static energy performance. Thank you for the question that opens other scenarios of research.
Okay, thank you also for the presentations and the participants for questions and live discussion. So the floor stays with you, and please present the last paper, which is scheduled for this session, please.
Yes, okay. Can you see the presentation now?
You have to stop sharing the previous one. Yes, now we see it.
Ah, okay, let me. Are you seeing the second one? Yeah. Okay, the
Yes,
digital twin for sustainability assessment. Okay, so thank you.
Now it is back to the previous one. Yes.
Is the previous one? Is it?
No, now it's okay.
Sorry.
It's okay.
It's okay. Okay, thank you. So the second contribution that I'm going to present here to Southeast European Conference of Sustainable Development of Energy, Water and Environmental System is this research about digital twin for sustainability assessment of cognitive educational buildings, the test case of our ELUX lab that you can see here in my virtual background also is our pilot at the University of Brescia, and worked on this paper with my colleagues of the University of Brescia, Stefano Rinaldi, Professor Angelo Ciribini, and Professor Prof. Alessandra Flamini. And then we have the contribution of Professor Fulvio Rececconi from Politecnico di Milano and Sebastiano Maltese from SUPSI, the University School of Architecture in the Italian Switzerland. So this is a multidisciplinary work, and we worked on our ELUX lab. ELUX means Energy Laboratory as University Expo. That is our pilot building that we are using to test technologies, energy saving, IoT, and the concept of the cognitive building. So as an introduction, we start as a first step into thinking about the global Green Deal, that in EU we need to reach the climate neutral and zero impact for our building with different strategies that are introducing that zero pollution, affordable and secure energy, smarter transport, and high quality food. So we can understand that the energy performance in building directive are only focused on the energy section of the evaluation of sustainability, but we know that we have the assessment rating system that are trying to include an holistic view of the sustainability of buildings. So we started into think about how to transfer the concept of this assessment tool into a wider evaluation that could be not only a static checklist, how it is in this moment, but maybe a dynamic tool that could assess in real time the changing values of the different criteria of evaluation of these assessment tools. We know that these protocols for sustainability evaluation, here we can see the BREEAM organization and structure. BREEAM is the main protocol in UK. But all the is an example. We have different areas of evaluation. For example, here we can see energy, water, waste and soil use and ecology, management, pollution, health and wealth, and transportation and materials. And each area has a different criteria related to the main topic. So we have this kind of relation diagrams that are useful for us to understand also, in some cases, if a measure for sustainability could have an impact on different areas. And we worked as first in a previous research about to understand how is the relation structure of these different tools for sustainability. Here you can see the diagrams for DG NB, which is the German protocol, the SBC, that is the Sustainable Building Council structure that has been customized in Italy with the Ithaca protocol that you can see here to the right side, and the BREEAM. And also we found different experience in Europe to try to harmonize these different tools that we have in the world that they are assessing the sustainability with the same kind of approach, but with different areas and different criteria, and sometimes calling with different names the same kind of section of sustainability. For example, the SESBA tool in the Building European project. Here we can see the LEED, which is one of the first protocol that we have started in US, and now is also, for example, in our country, in Italy, that is leadership in energy and environmental design. In this diagram that I worked on, we can see the different areas: the indoor environmental quality, sustainable site location and transportation, material resources, water efficiency, innovation, regional priority, and energy and atmosphere. And LEED, it's a very complex and interesting protocol, because inside the manual you can find the different relation between the criterion parameters. So in this tool, the process is also to understand how to try to work into increasing sustainability affecting different areas. But and also here we can see that these different evaluation area are shared between the different tools. For example, here we have the energy, environmental loads that is common between the protocol that I mentioned before. Then there is management and transport or innovation that is shared between 2 or 3 protocols. So the idea is to try to have a wider vision of this approach of sustainability. But then when we start into working directly into assessing the sustainability of the building, we found this checklist, because these protocols that are very complex are then organized as a checklist where we have a list of criteria, and we can get points for different section and strategies. And this is the same for the first and second generation of protocol. And here there is this example of LEED, but also for the third generation protocols and tools. Here you can see the WELL protocol and the Living Building Challenge version 4, where we have some of the same evaluation areas. For example, you can see water, light, materials, but there are also new section more focused on the user well-being. For example, here we have mind, nourishment, movement, sound. And so we have more traditional areas such as thermal comfort, but also other areas related to the user in the well protocol, for example. And in the living building challenge, we can see that we have a section areas about place, water, energy, health and happiness, materials, but also equity and beauty. So we can see that in the third generation, we are trying to increase the detail also on data that are more, it's less easier to evaluate as a quantitative criteria, but we need to include also the effect that we have with the building on the users. We recognize that we need to overcome this static vision, and we want to propose this idea of this from the static calculation to a dynamic monitoring approach of sustainability. Here you can see this diagram when we can see the shared and the areas of evaluation of the traditional and the first and second generation tool, and the well areas and the living building challenge areas, and we try to move from the calculation approach to the monitoring approach. So the idea is that for some of these criteria, it's possible to insert sensors or collecting, for example, information from the users for the section of fitness, or maybe about mind or health and happiness that are more related to this part of the user satisfaction that can be collected through app or other kind of tools. And for the other criteria, we can use a monitoring system to have this kind of dynamic information, as we are doing in our pilot building, for example, on the comfort condition for the thermal situation in the spaces, in the learning spaces, or in the visual comfort about illuminance, or CO2 concentration about indoor air quality. So the idea is to extend this, and we tested this framework of a green digital twin. So we want to use the sustainability criteria starting from the protocols and using the BIM information model to create this digital twin, where we have the asset information model and a cloud database where we are collecting data coming from the sensor that are installed in our building, and also trying to promote the sustainable behavior of our users. So to try to work on this cognitive approach of the building, that is, that the meaning is that the building is learning from the users' preferences and behaviors to increase efficiency and comfort conditions. So this is the framework of our research. And here vision of our pilot building and the ELUX lab, where we have the smart campus of the University of Brescia, distributing sensing, energy storage, smart controllers and solar test facility, and smart grid research, the virtual lab, and smart and prototype electrical vehicles, and the cognitive building, and the solar model. So we have a lot of activities, because in our laboratories are involved the 5 departments, and so we found that our vision is related and more wider than only the focus on energy, and for that reason we try to move to this sustainable, dynamic sustainable approach. Here you can see the real building and the BIM model, and we are working on this pilot building since 2015 with the founding regional programs, and we have inside the building some plants and IoT sensors that are producing energy, for example, with the photovoltaic plant for the electrical vehicle or for the electrical needs of the building. Then we have HVAC system, electrical storage, and then we have IoT sensors that are counting people, collecting information about the electrical consumption from the plugs, environmental sensor about indoor environmental quality, as I mentioned before, and the weather station about the data of solar radiation, wind speed and direction and temperature and so on, and the electrical load monitoring. So we use this, pilot building to test our idea, and we try to work also on the to understanding the data that we required for calculating the sustainability through the rating protocols. So we have 4 different sections. So the data required by the rating protocols and already collected in our digital twin. The data required by rating protocols not collected by the digital twin, but included in the IFC schema. The data required by the rating protocol not collected by the digital twin and not included in the IFC schema. And the data not needed for the rating protocols, but that can be useful to improve the user's behavior from a sustainability point of view. And so we worked on the data organization about the type, intended use, dimensional range, and variability over time to understand if it's better to store the data in the B model or in the database that are that we have presented in the schema to understand where it's better to store the data, or in the asset information model, or in the database. And we found that the data already in the IFC schema to be used by sustainability expert and with a slow variability over time are easily stored in the asset information model, while the data to be fed by users with a high variability over time and maybe not in the IFC schema are better stored in the database that is connected to the digital twin. Then here you can
Lavinia,
see,
please check the timing.
Okay, sorry. Okay, here you can see 2 ways of communicating the data that we are collecting from our IoT network. So, for example, here temperature, relative humidity, and CO2 concentration in the spaces, and also we are working on an app where the community the student, because our building is in the University of Brescia campus, and we can collect their feedback and also communicate with them about the occupancy and the comfort condition into the spaces. Here to sample results, we used the BEAM model to show and explain the comfort data. For example, the temperature, humidity, and CO2 concentration, and we used also here color coded to check if the conditions are correct for the comfort of the student, and we can also try to support with these thematic plans possible corrective actions to the HVAC system to provide a suitable indoor condition. And here another example about how to calculate and understand, for example, the criteria about sustainability of materials, checking the quantities and the specific materials that we have with the energy per environmental product declaration. Also, in this case, we make this thematic plan to understand the quantity of recycled material and sustainable materials. So the digital twin, as in this moment, some limitation because we started into working on the energy section that is a great part of sustainability, but it's not the only area and criteria that we need to assess. And the data collection have been developed with data mining for predictive maintenance, indoor air quality preservation, space organization, and people flow optimization with the focus on energy efficiency. So the sustainability assessment investment as we have now. So we have some problems that maybe could be overcome with the developing a link between the BIM and the checklist to try to inform directly, for example, the experts that are assessing the sustainability of the building, but also communicating to a more user-friendly tool, such as, for example, the app, to inform the users and provide a dashboard about sustainable behaviors and guide the user through the daily life in the campus. And this could be implemented with the existing monitors that we have in the ELUX lab. And our idea is also to propose a framework of how to implement this cognitive concept for the building and this dynamic monitoring system for sustainability. Here you can see my colleagues and all the team that worked on this research, and thank you for your attention. If you have any question.
Thank you for your presentation. I'm afraid we exhausted the time. If we have, yes, we have a question. Ashir, would you like to ask you a question in live? No, it was. Thank you very much for all the presentations in this special session with a very special dedication. Beyond publications, we also had the pleasure of seeing Professor Naim Afgan during the summer schools in Çeşme, Izmir. And not only for this presentation, but I just want to remind you that all the presentations from this session are put on our virtual platform, so you are invited to continue the discussions through QA platform over there. I'm sure that there are a lot of questions, and our authors would be happy to provide answers. And the second reminder is about the next agenda item on today's fourth Southeastern European SDEWES conference. That is the invited lecture of Professor Paul Ostergaard from Aalborg University on energy planning and transitions to renewable energy sources. So all of us are invited to attend, and with this I'm closing these sessions. I think all of us could have a time to take well-deserved coffee, and see you later at the invited lecture. Bye-bye.
Thank you. Bye-bye.